Okay, so our I can statement today is I can multiply fractions by fractions as well as fractions by whole numbers. When the super nice thing about multiplying fractions is we automatically, our brain thinks to like multiplying whole numbers. And yeah, that kind of is like toyed in there with just like multiplying. But I promise you it is super easy and super friendly once you realize that you're just multiplying the numerators and then you're just multiplying the denominators. So multiplying straight across. So if I had the fraction, let's say 3/5 times 2/6. When we were adding fractions or even subtracting fractions, we always looked at our denominator to make sure that they were the same. When we are multiplying, they don't have to be. If they are, great, buy a lotto ticket. If they're not, don't even worry about it. So like I said, you're multiplying your numerators in together and then also your denominators, which you're in turn, you're just multiplying straight across. So 3 times 2 is 6. 5 times 6 is 30. That's it. So again, you'll be leaving your problem in 6/30. Obviously, when you get into like 6th grade and middle school, they'll teach you how to simplify that. But 6/30 is exactly where we need to be. Another problem, so let's say we had, let's say 5/10 times 2/4. Again, looking at just your numerators and then just your denominators, you're going to multiply straight across. 5 times 2 is 10, and then 10 times 4 is 40. So 10/40. Both of those direct examples of how we are looking at our numerators, multiplying across, and then looking at our denominators and multiplying across. When we get to having a fraction by a whole number, so let's say I have, 5/7 times 3. Don't panic just yet because we always look for our numerators and our denominators. And in this case, it's just a whole number 3. But what they didn't tell you is that whole numbers have a sneaky, invisible, mysterious denominator of 1. Every single whole number has a sneaky denominator of 1. So now in this case, we have our numerators, we have our denominators. Let's multiply straight across. 5 times 3 is 15. 7 times 1, our sneaky denominator, is 7. In this case, this is an improper fraction, which means our numerator is bigger than our denominator. So you can either leave it in an improper fraction or you can change it back into a mixed number. A mixed number, again, has a whole number as well as a fraction. So it's like a two-part system. So if I wanted to change this into a mixed number, I'd say, how many times does 7 go into 14 or 15? Well, that would be twice because 7, 14, 21 would be too big, so we'd have twice. And then how many left over? So if I had 14, so 2 groups of 7 is 14, 1 more would be needed, so 1 out of 7 to give me my answer. Another way for us to check it, 7 times 2 is 14. 14 plus 1 is 15, denominator 7. They match. So even if the whole number is the first number, so let's say 6 times 3/9, it doesn't matter. Whole numbers have a sneaky denominator of 1, so now you can multiply straight across. 6 times 3 is 18. 1 times 9 is 9. So you can leave it as an improper fraction, which is 18/9, or change it into a mixed number, or in this case, it's just a whole number. 9 goes into 18 twice. So the golden rule when you are multiplying your fractions, whether looking at your whole numbers times a fraction or a fraction times a fraction, make sure you have numerators, make sure you have denominators, and multiply straight across.